It's well known that Gottfried Wilhelm Leibniz invented one of the earliest calculating machines, a device capable of performing complex arithmetic mechanically. But that's only part of the story. Beyond this famous invention, Leibniz imagined a whole range of devices, some practical, some visionary, and some that seem astonishingly modern. In this video, we'll explore a few of his lesser-known inventions: his binary calculating machines, a tactile binary clock, a terrifying war machine known as the fire cart, and finally a form of ballistic clothing made from silkworm cocoons. Let's start with the binary machines. Leibniz, of course, didn't just devise mechanical calculators. He also revolutionized the very idea of calculation. He invented binary arithmetic using only zeros and ones. And crucially, he realized that binary arithmetic could be mechanized even more easily than ordinary decimal arithmetic. In one design, he imagines wheels marked simply with alternating zeros and ones, where each rotation naturally produces the carries needed for calculation. In binary, everything becomes simpler. Instead of dealing with 10 digits, the machine needs to deal with just 2, 0 and 1. Leibniz even devised mechanisms where parts of the machine would engage or disengage automatically, depending on whether a digit was 0 or 1, effectively allowing the machine to ignore certain operations when needed. He also explored more abstract designs, using falling balls, channels and gates to perform calculations physically. What we see here is something remarkable, a conceptual ancestor of modern computing. Leibniz didn't just stop at machines for calculation. He also thought about how numbers could be perceived differently. In one ingenious idea, he proposes a tactile binary clock. Instead of reading the time with your eyes, you could feel it with your fingers. The clock would have a set of points. Some were hollow, some were raised. Each position represents a binary value, 1, 2, 4, 8. By feeling which points are raised, you could add them together to determine the time. For example, if the points representing 4 and 8 are raised, that gives you 12. It's a simple idea, but a powerful one. A clock you can read in the dark, or even in your pocket. One that could be read by the visually impaired. This is Leibniz thinking not just about machines, but about human experience and accessibility. Now we move from calculation to combat. Leibniz's fire cart is one of his most striking and unsettling inventions. He describes a heavily armoured vehicle powered by gunpowder, capable of carrying 20 men into battle. Once set in motion, it would accelerate rapidly, crashing through enemy formations, throwing grenades and spreading chaos. It would smash, overturn and wound, even dragging spiked chains to tear through entire battalions. Leibniz himself compares it to an iron elephant, a terrifying force on the battlefield. And what's remarkable is how seriously he considers its design, its protection from gunfire, its steering mechanisms, how to cross obstacles, even how to escape after the attack. He acknowledges it may sound unbelievable, but insists he sees no reason it couldn't work. To modernize, this looks like a distant ancestor of the tank. Finally, Leibniz turns to defense. Not machines, but materials. He asks a bold question. Can we make clothing that stops bullets? His answer begins with silk. Leibniz observes that silk is incredibly strong, but that silkworm cocoons in their natural form are even stronger still. Instead of weaving silk into fabric, he proposes using the cocoons directly, pressing them together into layers to form a dense, flexible material. The idea is simple, but ingenious. A bullet wouldn't just pass cleanly through, it would have to tear apart layer after layer of tightly bound fibers, losing energy at every step. Leibniz even outlines a method. Compress the cocoons into sheets, layer them so weak points are covered, and then press them repeatedly into a unified fabric. The result? A material that could be light, flexible, and resistant to musket fire. In effect, Leibniz is anticipating the principle behind modern ballistic fabrics. What do these inventions have in common? They show Leibniz as more than a philosopher, more than a mathematician. They reveal a mind constantly asking, how can ideas be put into practice? How can theory reshape the world? From binary calculation to tactile technology to armoured vehicles and bullet-resistant clothing, Leibniz wasn't just thinking about knowledge. He was imagining what it could build. And in doing so, he reminds us that even the most abstract ideas can lead to the most concrete inventions. Leibniz's inventions were by no means restricted to the ones mentioned here. He also conceived a combinatorial machine that calculated with letters. He conceived a pocket watch and many other things besides. I hope to get to these in a future video. In the meantime, if you want to look further into any of the inventions mentioned in this video, please check out the links in the video description.